Okay, so I want to talk about, this is getting into 7.4, thinking about these trig relationships as functions. So I want to start with f of x equals x squared and remind you that with functions, there's a couple of things to keep in mind. First of all, input is x. The output is f of x. In this case, it's x squared, right? So in other words, the rule here is that we take this number and multiply it by itself. Take the input and multiply it by itself, right? So one second. Okay, so when I say something like f parentheses 3, that's f of 3. That's saying take my rule and put 3 into it. So of course that just means that we're going to square 3, so we get 9. So this is the input and this is the output. We can create a mapping of this. These are all my inputs. Videos in the way. When I put in 3, I get out 9. When I put in 4, I get out 16. When I put in -1, I get out 1. When I put in 2, I get out 4. Right? These are my inputs. These are my outputs. The words domain and range mean the set of all possible inputs and the set of all possible outputs. So let me just write that down here. All right. So when we're talking about domain and range, we typically use special interval notation. So for instance, here I would say that x is a member of all real numbers, or exists in, is how I kind of remember this symbolic representation of this little e symbol. So this is a r with the extra line behind that vertical line. This is just all real numbers. In interval notation, I might say -infinity to infinity. These are the exclusive container bounds because I can't include the number -infinity and infinity. Those are concepts, not numbers. And then the set of all possible outputs here, it's a little more interesting because actually I cannot get negative outputs. So my range goes from 0 included. So 0 is a possible output all the way up to infinity, which means it goes as far up as we want, right? And then if we turn just briefly to the graphical representation, where's my decimals? There it is. I'm going to get rid of this. Let me just refresh. It's fine. And there we go. So I'm going to take a look at f of x equals x squared. Right, this is my graphical representation, which of course, in a way, is just a glorified mapping of, well, basically every single input and every single output in the range of like what I've graphed. So, right, we're seeing lots of solutions or lots of input-output pairs, right? When I say solution, it's more of the framing of like y equals x squared. There are solutions to that equation. We're talking about functions, we talk about inputs and outputs. Okay, x, f of x, x, y, right? -1, 1, -2, 4, 0, 0, 1, 1, 3, 9, 4, 16. And so the graph is just the collection of all of those, infinite number, right? Because inside any little interval, there's lots and lots and lots of solutions or input-output pairs that would make that work. Okay, so let's talk, while we're here, so we might as well use decimals. Let's talk cosine x and sine x as functions. Okay, I'm going to refocus here. I'm also going to change my settings. Really, I don't need to go all of that. That's overkill. -2 up to 2 is fine. And this step here, I don't really need to go from -37. I could just do -5 to 5. And I'm going to make my steps pi quarters. Okay. Oh, actually, let's do pi 6. All right, great. So here is sine, Mr. Sine. This is sine's representation as a function. So this is a collection of input-output pairs. If you think about the unit circle, I can ask about the sine of any angle. You know, give me this angle. Yeah, I can do it. What about this angle? Sure, no problem. What about this angle? Yep. I can go around and around and around and around and around and land here, and that's a different angle. I can go backwards, right? Those are negative values. So there's the domain of this function is all real numbers. There's no limitation to what I can put into the function, but there is a limitation to what comes out of the function, which is that I have to be somewhere between 1 and -1, inclusive of 1 and -1. Okay, and that's true for sine, same as it is for cosine. And we're going to talk about these functions a lot more in chapter 8, and especially in terms of translations and transformations. So we'll spend more time like digging into the representations of those things. But this is the same. The domain is all real numbers because I can take anything I want into my x value, any angle that I'm interested in, I could find. Keep in mind that when I'm doing this functional representation, I think about my inputs in terms of radians, not in terms of degrees. And my output is still somewhere between -1 and 1, because if you think about the unit circle, the biggest value I can get in the unit circle is, in terms of cosine, the x value is 1, and the smallest number I can get is -1. Same is true on the vertical scale. Biggest I can get is 1, and the smallest I can get is -1. Okay. Let's finish by talking a little bit about symmetry. So if we think about the meaning of symmetry, and I'm going to stop the share here. Go back to my whiteboard. So there are these even and odd functions. Not every function is even or odd, but even and odd are types of symmetry. And I think the reason these are called even and odd is based on the evenness of the powers. These functions, subscripts, so I can just keep using f over and over again, are all even, right? So they all look like basically the same thing. It's just a little bit flatter. When you start to do x to the 4th, x to the 6th, it gets flatter. Odd functions, x to the 1, x to the 3rd, x to the 5th, these are odd powers. Just using subscripts in case I want to talk about these. I'm not really going to talk about them, so it doesn't matter. So these, this is f of x equals, this is f of 4, sorry, not f of 4, f sub 4 of x. And then the cubic, I come in, come out. That's a cubic function. Okay, so these are odd symmetry, these are even symmetry. What does it mean? This is a reflection about the x-axis, reflection about the y-axis, which is a horizontal symmetry. So this is what happens when it doesn't matter whether you plug in a positive value or a negative value, you get the same thing, right? And that's, I kind of mentally think of that as f of x equals f of negative x. When I put in a negative, it gets kind of swallowed up by the function. Negative signs get swallowed. Right? Then in terms of odd symmetry, what happens here is, well, first of all, this is rotational symmetry. Which is symmetry about the origin, spin 180 degrees. And what it looks like symbolically is that when I stick in a negative value, the negative basically pops out. Okay, so that's, again, those are kind of words that I say to myself when I put in a negative value. So the significance here is that, you know, when I take x to the 5th power, right? So if I take f of 6, f6, put in -2, -2 to the 5th power is the same as negative 2 to the 5th power, right? So that's the meaning of it. It's like the raising something to the 5th power. It's like the negative, it's not irrelevant. It just, you can think of it as coming straight out. So the implications here for these functions that we have, cosine x turns out to be even and sine x turns out to be odd. So interesting little partnering there, because not every function is symmetrical. So it's just interesting that one's even and one's odd. Okay, that's it for our introduction to functions. Next, we're going to talk a little bit about tan and some of the other guys, and then we'll do some more practice problems.